Welcome to this presentation on scientific observatory electronics and recycling protocols. Today, we explore how high-precision observatory equipment reaches the end of its life, and how responsible recycling ensures scientific progress continues without harming the environment. Scientific observatories are crucial to discoveries across astronomy, seismology, meteorology, and environmental research. These facilities rely on highly specialized electronics, detectors, processors, sensors, and control systems that operate with extreme precision for years at a time. Although designed for long lifespans, all equipment eventually reaches a point where it must be upgraded, replaced, or retired. When that moment comes, observatories face the challenge of handling this unique, high-value e-waste responsibly. Observatory electronics differ greatly from commercial devices. Their components often contain rare earth magnets, gold-plated connectors, and custom semiconductors that offer unmatched precision. These systems are built to withstand harsh climates, mountaintops, deserts, or isolated research stations where durability is essential. This performance-first design, however, makes recycling difficult. Many components are embedded deeply within sealed housings or reinforced enclosures, not intended for easy disassembly. Once equipment becomes obsolete or irreparable, decommissioning is rarely straightforward. Most observatory staff specialize in science and engineering, not electronics recycling, which means establishing proper protocols can be challenging. Remote observatory locations complicate transport, especially when hazardous components are involved. And because many devices were never designed with end-of-life handling in mind, teardown can risk damaging reusable parts or releasing unsafe materials. To address these challenges, observatories rely on structured recycling protocols. Standardized workflows ensure electronics are disassembled safely and systematically. Sustainability goals emphasize reuse whenever possible, reducing waste before recycling even begins. Detailed documentation tracks every component throughout the process. And most importantly, observatories partner with licensed recyclers to ensure proper handling, processing, and environmental compliance. Before recycling begins, a complete inventory of equipment is performed. Each device is logged with its function, condition, and age, helping determine whether it should be reused, upgraded, or retired. High-value components like actuators, sensors, and lenses are identified early so they can be preserved for future use. Systems are sorted into subsystems such as power units, controllers, and data modules, which makes later disassembly far more efficient. Scientific observatories often store sensitive or proprietary research data. For this reason, data sanitization is a critical early step. Storage devices such as hard drives or memory modules are securely wiped or physically destroyed to prevent unauthorized recovery. Every sanitization action is logged to meet institutional, governmental, and multi-agency security standards. Disassembly must be performed with care, especially when dealing with fragile or sealed equipment. Circuit boards, timing systems, and controllers are removed piece by piece, ensuring nothing is damaged in the process. Specialized tools are used to safely open custom enclosures or extract embedded components. Power supplies, cabling, and transformers are isolated first to eliminate electrical hazards. Reusable assemblies are preserved, extending their usefulness beyond the observatory. Once disassembled, materials are sorted into specific categories. Non-ferrous metals like copper and aluminum are separated for recovery. PCBs, plastics, and glass are organized based on their chemical and structural properties. Hazardous substances, such as mercury switches, cadmium batteries, and calibration sources are isolated and secured for specialized disposal. Rechargeable lithium systems are handled separately to prevent fire or chemical leaks. Handling hazardous components requires strict safety procedures. Emergency protocols outline how to respond to leaks, breakages, or chemical exposure. All hazardous materials are stored in approved, secure containers until transfer. Compliance with environmental regulations ensures materials are disposed of safely and legally. Only licensed recyclers are permitted to process these substances, guaranteeing proper treatment throughout the disposal chain. Recycling observatory electronics is a collaborative effort. Licensed recyclers provide the specialized tools, training, and regulatory knowledge needed to process complex equipment. They offer full chain of custody documentation so every component is accounted for from start to finish. These partnerships maximize material recovery, reduce environmental impact, and streamline future observatory upgrades. Whenever possible, reuse is more sustainable than recycling. Many decommissioned components still hold immense value for universities, engineering departments, and STEM programs. Citizen science groups and public outreach centers can repurpose sensors, racks, and instruments for hands-on learning. Smaller observatories often rely on donated equipment as backup systems, and these contributions extend the lifespan of highly specialized tools. The future of observatory electronics depends on designing equipment with its entire life cycle in mind. Modular layouts make disassembly easier when devices reach end of life. Reducing hazardous materials lowers disposal risks and improves recyclability. Standardized connectors and clearly labeled components simplify sorting and handling. By planning for recycling from the very beginning, observatories can align their scientific mission with sustainability. If your organization is ready to responsibly manage scientific or observatory electronics, we're here to support you. Reach us by phone, email, or online to schedule equipment pickup, recycling services, or secure data destruction. Thank you for watching. Responsible recycling empowers science to advance without leaving a harmful footprint behind.